Hello, grade nines. I hope everybody's doing great out there. This is Mr. McCarville speaking. This video is going to go over the example that's done for you on your linear scavenger hunt assignment. This is distance learning assignment number 5. So I've set it all up so that you can click on the Google Slides. So it's done with Google Slides. So when you click on the link from Classroom, this will come up. So everybody will have their own to work on. So just you can manipulate this whatever way you like. But if you go down to page number 6, this is page 6 here. So there's 5, there's 6, and number 6 is an example. It's all done for you. So the idea is for you to match the word problem with its equation, with its table, with its graph. So this is one that's all done for you, and it's on your assignment there for you to take a look at. So let me read the word problem for you. Kennedy just got a job selling programs at the ACC during the Toronto Raptors games and is paid $15 plus $0.5 for every program he sells. Or in other words, 50 cents for every program that he sells. So this is a good example of a partial variation linear relation. Now, a partial variation means that it does not start at 0. So direct variation means it starts at the origin or at 0. That would be the case if Kennedy was only paid for every program that he sells. But in this case, he gets paid $15 right off the bat without selling any programs, and then earns 50 cents for every program that he sells. So, in other words, he really can't, as long as he shows up to work, he's going to get paid at least $15 that day. So, if you look at the equation here, this equation should make sense. Now, I didn't write down what the variables mean, but the P probably stands for paid, what he gets paid, Kennedy, and the N is the number of programs that he sells. So there's two different variables here, two different letters, because there's two unknowns, and the unknowns are how much he gets paid, and that depends really on how many programs that he sells. So this equation is nice because if you see it's got the 15, that's what we call the fixed amount. So 15 is what he gets paid no matter what. And if you notice, it's a number all by itself. So he gets paid $15 plus the 0.5 is something that we call the rate of change. And the rate of change for this question is 50 cents for every program that he sells. So the rate of change here is 50 cents or $0.5, and it's written right beside the other variable n. And the n stands for the number of programs that he sells. So the amount he gets paid will change depending on how many programs he sells. So let's think of an example. So for maybe he sold, let's make it easy. Let's say he sold one program. Well, one program times 50 cents or $0.5 is 50 cents plus the 15, he'll make a total of $15.50. Now, if he sells 10 programs, well, 10 times 0.5 is $5. Plus the 15 he gets, the fixed value, will be a total of 20. So this equation matches nicely with this word problem. Now, if you scroll down here, the table, and notice how there's some missing values here. I'm going to fill those in here in a second. But this table also matches this information, the word problem and the equation. Now, if you notice, if he sells 0 programs, that's the N, he makes $15. So that's a typical partial variation. If partial variation means at 0, there's an amount there. If this was 0, 0, then it would be direct variation. So, okay, so 0 programs, it makes sense he'll get paid $15. And if you look at the equation, 0 times 50 cents is 0 plus 15 is 15. Now, if you look at this other one, this 20 and 25 that's done for you, if I plug this into the equation, if I put 20 in for n, 20 times 0.5 is 10, if you put that in your calculator, and 10 plus 15 gives me 25. All right, so the only other one in here that's filled in completely is the 40 and 35, and I'll just quickly go over that. 40 times 0.5, 40 programs times 0.5 is $20, plus the 15, he'll get paid $35. right? So that definitely is the table that matches that equation, which matches that word problem. Um, Now, the last thing here, and I'm going to come back to filling these spaces here up in a second, but the last thing we need to do is match the graph. Okay, so I'm going to go through. If you look at all these graphs here, now this one won't be here because it's already been it's used for my example. But you're going to go through all of these, right? And so you're going to find the right one for yours. But for this one, let's see if the graph makes sense. Now, the easiest thing to look at is look at time at 0, what your amount is at. So because if you look, 0 is at 15. So I had to try to find a graph that had 0 on the x-axis corresponds to a y value of 15. So for these letters, if n is 0, so this would be the number of programs down here, and this would be his pay. If he sells 0 programs, he still gets paid 15 bucks. Now I'm also going to look for other values that are on here. So how about 20 and 25? 20 programs go up. Sure enough, it's at 25. 40 is at 35. So I'm convinced 40, 35, right? So I'm convinced that this is the graph that represents this table, that represents this equation, and all three of these represent this word problem. Okay, now if we were to do the rise of a run here, if we were to find the rate of change using rise of a run, it would give us that rate of change of 50 cents per program. So that's another way you could figure out which graph belongs here. But lastly, guys, let's fill out these values here. And if you want to fill these out, all you're going to do is go insert text box, and you're going to put a text box in there, and then type in the value that you think it is. So I'm just going to fill in. I know that there's going to be 10 programs will give me a pay of 20, right? Because if my pay is 20 and if I get paid 20, then it's 15 plus 5. So 10 times 0.5 gives me 5. So the only number that would work here is 10. And then insert text box. I'm going to put the next value in. Now it's nice with linear relations, there's always a pattern. So if you look, 0, up 10, up 10, up 10, and our values in pay are just going up by 5 every time. So my answer here is 0 is 15, 10 is 20, 20 is 25, 30 then will be 30. And then 40, of course, is 35. Now, the trickiest of the two are the two in yellow. Now, the reason why they're tricky is because you can't use the pattern because they jump by so much. So if you want, you could, on a separate piece of paper, fill out all the missing values in between 40 and 80 and figure out what they are that way, and then climb your way up to this one. And then you can also do that and keep going by 5s up to 120 to figure out what the n would be here. But another way to do it is use the equation. So if I put 80 in here for my n, 80 times 0.5 is 40. 40 plus 15 gives me 55. So I'm going to insert a text box and put in 55. And lastly, by playing around with this a little bit, if I was going to get paid $120, then if I put 120 in here for P, I got to figure out what the N is. All right. So the best way to do that is maybe subtract 15 from the 120, which gives me 105. If I were to now divide that by 0.5, I would actually get 210. So that might be tricky for some of you, but maybe just play around with some numbers. Try, say, 200. Well, 200 times 0.5 is 100. 200 times 0.5 is 100. 100 plus 15 is $115. Well, that's not quite high enough, right? So then we know that, okay, well, let's try 210. 210 times 0.5 is 105. 105 plus 15 gives me 120. So we can get it that way. So that is what you have to do for each of the 8 relations. So if you look, guys, there is here is on page 2 is 8 different word problems. And page 3, 8 different equations. Page 4, 8 different tables of values. And page 5, 8 different graphs. 8 different graphs. So your job is to, on each of these other pages, this is page 7, this says linear relation number 1. Pick whatever word problem you want, and then find its equation, find its table, find its graph, and then fill out its table. So you're going to do that for all 8 of the relations. So there's one on page 7 will be 1, page 8 will be 2, page 9 will be 3, page 4, page 10 will have 4, page 11 will have 5, page 12 will have 6, page 13 will have 7, and page 14 will have 8. All right, good luck with all of this. Bye for now.